Now we shall see how to solve this system of linear equations. System of linear equations Ax equal to b, or as we have to know previously, without the matrix representation, without the matrix represented form. And this is the matrix represented form, and without matrix represented form, the system of linear equations we have already know that we have seen in our first lecture. Okay. Now we shall know how to solve this system of equations Ax equal to b. To solve this system of equations, the first and foremost we have to be acquainted with some terminology as a preliminary notion. I am now telling you all those things. Okay, this is augmented matrix A bar. Augmented matrix A bar. We now see how to form this augmented matrix. This is the associated matrix A. This is the associated matrix A of the system of linear equations, and this is this. This is this matrix. Okay, and this is the matrix B. This is the matrix B, which has been formed taking all the members, all the right hand members of the system of equations B1, B2, so on, Bn. We are now forming the matrix A bar, which is called the augmented matrix, taking this B1, B2, so on, Bm as a extra column of this matrix A. That means we are adding an extra column with this matrix A, and the very column is this B1, B2, so on, Bm. Okay. This is the augmented matrix A bar. A11, A12, so on, A1n, B1. A21, A22, so on, A2n, B2. AM1, AM2, A so on, AMn, Bm. And this augmented matrix sometimes notationally is written as AB. This is the augmented matrix A comma B. Okay. And the very system Ax equal to b of linear equations, this is a non-homogeneous system when this right hand member b is not equal to the null matrix. That means there are some right hand members of this system of equations which are non-zero, and if the right hand members of all the equations of the very system is 0, that means if this matrix B is the null matrix O, then we shall call that this system of equations is a homogeneous system of equations. When B not equal to the null matrix, we shall call that the system of equations Ax equal to b is a non-homogeneous system of equations. And if this B matrix B equal to the null matrix, then we shall call that this system is a homogeneous system of equations. Now, when two systems Ax equal to b and Cx equal to d will be called equivalent system. We have already familiar with the row operations or column operations of a matrix, and when two matrices are called equivalent, row equivalent, column equivalent, etc. We shall recall here the very notion. We are considering the augmented matrix for this first system of equation Ax equal to b, and also we are considering the augmented matrix for the second system of equations Cx equal to d. For this first system of equations Ax equal to b, the augmented matrix is this A comma b, and for this second system of equations Cx equal to d, the augmented matrix is this C comma d. And if these two matrices A comma b and C comma d be row equivalent, as you already know, when two matrices are called row equivalent, if these two matrices are row equivalent, then we shall call that these two systems of equations are equivalent systems. Okay. And here we shall also be familiar with an important result that we everybody have to kept in our remembrance. That is this. If Ax equal to B and Rx equal to S, this is a nothing but two system of equations if they are be equivalent systems, and if we have a solution for this system of equations, that means for any one of this system of equations, if we have a solution for any one of these two systems of equations, then that very solution would also be a solution for the another system of equations. Here I have written in this line as if alpha be a solution of this system of equations, then alpha would also be a solution for the second system, Rx equal to S. Okay.